This module will familiarize you with the deployment architecture strategy of Claroty's Continuous Threat Detection, or CTD, solution. Before we begin, let me mention that this is an introductory module. If you are looking for specific technical details regarding CTD components, best practices, and other advanced technical information, we will be covering them in the more advanced CTD-related modules. CTD is built around 4 functional pillars that explain how Claroty is able to collect and work with data from a process control environment. These 4 pillars are Reveal, Detect, Protect, and Connect. The most basic notions behind the Reveal pillar are that you cannot protect assets that you don't know are present within your system. Further, users frequently need to know what is present in their system from the point of view of maintenance requirements, legal compliance, and quality standards. This module is composed of 2 sections. First, we'll learn about the various components that are deployed as part of a CTD solution. Next, we'll learn about the different methods that a CTD installation connected to your system will use to collect data. Claroty's Continuous Threat Detection, or CTD, solution has 3 main components. Let's start with the one seen in the middle. CTD Server is the main component of the CTD solution, the only CTD component that is absolutely essential, and the only CTD component that can be deployed as a standalone solution. The CTD server provides almost all of the capabilities needed to facilitate IT and OT data acquisition and data dissection from your site. CTD server also supports UI management, meaning that you have a user interface from which you can log in and use the system. The CTD server is typically connected to the core switch of the OT network. It monitors the data passing through that core switch and collects relevant information to provide you with visibility into your asset hardware complement. The next component is EMC, or the Enterprise Management Console. This allows cross-organization visibility and monitoring. It is a management application that allows multiple CTD installations to be controlled in the same manner as one installation from the same UI with the same ease. EMC is always connected to at least one, but usually to more than one CTD servers, from which it synchronizes the databases between the various CTD installations. The EMC cannot dissect data. It always has to be connected to at least one CTD server, meaning it cannot be a standalone solution. However, it is capable of a limited range of actions across the databases to which it is connected, such as deleting assets, changing device names, and generating reports. The third component of CTD is the CTD sensor. The sensor is used in cases where data from remote OT devices or switches must be captured and dissected, but for some reason, the relevant data cannot be captured from the core switch. In these cases, a CTD sensor installation is deployed on a non-core switch. From there, the data is spanned from the non-core switch to the CTD sensor and relayed back to the CTD server. Once this process is complete, visibility is provided into previously unreachable parts of your network. A CTD sensor can provide basic dissection of events that are called within your environment and can push them back to the CTD server. However, the CTD sensor does not have UI management capabilities and cannot be deployed as a standalone solution. Claroty also offers technical integrations that allow you to fuse CTD with third-party security solutions or with Claroty's Secure Remote Access, or SRA, solution. Taken to the extreme, a typical deployment scenario for large organizations might involve multiple CTD sensors connected to a CTD server, with multiple servers connected to a single enterprise management console. This would allow a single operator, based at a single location, to potentially monitor the cybersecurity posture of the very largest multinational corporations. To understand the reasons behind different Claroty deployment architectures, it helps to know the differences between the available asset detection methods. Passive detection is the most frequently used data collection method and also the easiest one to implement. Passive detection is non-intrusive and therefore risk-free because it gathers traffic but does not introduce any. It also allows real-time detection of events, behavioral anomalies, and threats as they occur. A disadvantage is that although passive detection continuously dissects incoming data, it cannot show device status changes on demand, meaning that you have to wait for the relevant devices to communicate before information on them can be gathered. Active detection is capable of gathering information of higher detail and is capable of gathering that information on demand. The disadvantage of active detection is that it is intrusive, meaning that it introduces additional traffic into a network environment that is typically not fault tolerant. Therefore, some technical knowledge is needed to safely implement this approach. AppDB works by extracting device data from device project files. Project files contain configuration settings that govern the specific actions PLCs take within the production environment. The AppDB solution is particularly useful in cases where device information is hard to get. For instance, if a CTD server or CTD sensor cannot get data from a small segment of your network due to the design of the network. What we see here is a basic example of CTD solution deployment. If an EMC is used, it is typically located at the enterprise network, that is, at Purdue Level 4. The deployment approach seen here is the most basic, and also the first installation approach Claroty typically proposes in any project. The main goal is always to connect to the OT core switch. If needed, this also allows a phased deployment approach by gaining most of the needed visibility from the core switch. This approach also ensures a quick and efficient return on investment, with the lowest possible time expenditure and the highest value. Deployment times are typically very short, and approximately 80% of device visibility will be gained immediately. The ultimate aim is always to have 100% visibility. However, starting out with a CTD server to core switch installation allows a phased approach while also conferring a good initial understanding of device count and network layout. Purdue Level 2 of this diagram shows a good example of the phased approach. Level 2 contains two switches from which we want to gather data, but the core switch doesn't provide visibility into this traffic. The way around this obstacle was to install CTD sensors on the Level 2 switches and span data from the lower level switches to those sensors, routing the data back to the CTD server. For other segments of the network, alternatives would have been to use active detection or AppDB to complement our use of passive detection. These approaches are outside the scope of this module, and more advanced deployment methods will be covered in the later modules. So, to give a quick recap of this module, Claroty's CTD solution uses three main deployment components: the Enterprise Management Console, which provides visibility into your organizational deployment, one or more CTD servers that can be connected to the EMC, and one or more CTD sensors that can be connected to any CTD server. Claroty also uses three different detection methods: active, passive, and AppDB. Individually or altogether, these detection methods provide you finely detailed visibility and asset monitoring capabilities. With that, we conclude the section on CTD deployment architectures, and thank you for your time.